So, tolerance describes a type of error that is allowed in terms of comparing a measurement to our expected outcome. Um, like an example would be some machines are set to have a tolerance. So, maybe a machine's working to build something that's supposed to weigh 3.2 ounces. But there might be some way of setting the tolerance that it can differ by 0.1 ounce. So that means the machine is working in a way that it's aiming for 3.2, but if it goes to 3.3 or 3.1, that's not too bad. And in fact, it's okay in terms of how the system's set up. So the word tolerance is going to be this idea of something that we worked with before, which is plus or minus, going a little above or a little below our expected number. So, for example, here we have the measurement of a needle is 125 millimeters with a tolerance of 5 millimeters. So what we can do is describe the shortest and longest length acceptable for this. So the idea is taking this 125, and then this tolerance of 5 millimeters is how far above and below that value we can go. So that's where plus or minus comes in, is that we can do plus or minus, which splits into two scenarios. For shortest, we would be subtracting. For longest, we would be adding. So with that, this would be 120, and this would be 130. So it would be the shortest, longest. Let's say it could be 120 to 130 millimeters long. So with that, taking the tolerance value and you're just adding or subtracting it to your measurement or expected value. All right, determine the relative error of a needle that measures 131 millimeters. So this, I'm just connecting that previous video for a little bit more practice. So we have this measurement here. And we can see that this measurement actually goes beyond the tolerance. So that means we're letting a little bit too much error come through. So when we see this percentage, we'll kind of expect it to be a bit big. So we're going to take the measurement minus expected over expected. And with that, we will get out a 0.048, move the decimal over 2 spots. So this will be 4.8% error. And this gets to a spot where maybe that doesn't sound like that much error, but to others, maybe that seems like a lot of error, like almost 5% error. That's too much. They need to adjust their system. If they want this tolerance of 5 millimeters, but they got this 131 out, something's not working right. All right. The weight of a specific car type is 2,585 pounds with a tolerance of 63 pounds. So what is the lowest and highest weight acceptable? So again, with this, we're taking that expected value plus or minus the tolerance. So we'll split it up. So we'll do subtraction for the lowest and addition for the highest. So with that, we'll get 2,522 and 2,648. So the car should weigh between 2,522 to 2,648 pounds. Then if they get out a car that is 2,652 pounds, what's the relative error? So with that, we're taking this measurement that they actually have. So 2,652 minus our expected value of 2,585 divided by 2,585. I'm just going to write some of those decimals down. So 0.0259, let's just go there. And I'm going to move that decimal to the right 2 spots. So this is 2.59%. Which you can notice with this one that we are over like that maximum value. We're kind of getting at the top end of that tolerance that we're allowing. However, you can notice that the percentage is a lot smaller here. Again, it's this idea of scale. Like, even though this was just 1 millimeter beyond the tolerance, in terms of a measurement like this, that's a large amount in terms of the scale we're working with. Whereas here, working with a bunch of pounds, like over 2,000 pounds, yes, we were over by 4 pounds there, and that would be a percentage error, but it's not as bad because the scale is so big, it's less of a difference.